They were everywhere, and yet almost no one has heard of them. Tiny fossils, tooth-like, razor-sharp, scattered through ancient rocks like broken glass. For more than a century, these fragments teased the world's geologists. Were they teeth, claws, spines, the remains of a worm, or a fish, or something that belonged to neither? They're called conodonts, a name built for a mystery. In the dark layers of Paleozoic seas, they appear by the billions. But for most of scientific history, conodonts were known only by their elements. Minuscule hard parts, no larger than a grain of sand. A creature defined by what it left behind, not by what it was. Imagine trying to identify an animal from a single fingernail, and yet these fragments mattered because they became timekeepers. Their shapes shifted through the ages in reliable patterns, letting scientists date rocks with precision. Oil companies depended on them. Paleontologists obsessed over them. A fossil that could guide you to the past and still refused to show its face. So what on earth were the conodonts? To find out, we have to sink beneath vanished continents into oceans that no longer exist, to a time when complex life was still experimenting, and the rules of animals were not yet fully written. Somewhere in those seas, something small carried a mouth full of blades, and the planet kept its secret for hundreds of millions of years. At first glance, the conodont elements look like teeth. Curved cusps, serrated edges, tiny combs and spears. But teeth belong to jaws, and jaws belong to vertebrates, or so we thought. In the 1800s, some researchers argued conodonts were fish. Others said worms. Others imagined they were parts of crustaceans, or the spines of strange, jelly-like animals. The problem was simple. No body, just the hard parts. Detached, mixed, and scattered. A puzzle with most of its pieces dissolved by time. Then came a clue, hidden in arrangement. In rare rock deposits, where mud settled gently and oxygen was scarce. Conodont elements were found together in clusters, as if still held in a living mouth. Not one tooth, a whole set, paired structures, rows, symmetry. This was not random debris. It suggested an animal with a feeding apparatus, a machine built for gripping, slicing, and crushing. And the elements themselves held another secret. Under the microscope, they reveal growth lines like enamel and chemical signatures like bone. They were made of apatite, a calcium phosphate mineral, the same basic mineral in vertebrate teeth and skeletons. But if conodonts were vertebrates, then they were among the earliest. And that raises a deeper question. What kind of vertebrate could be so abundant, so successful, and still vanish into ambiguity? To answer that, the fossil record had to do something it rarely does. It had to give us a body. In the 1980s, in the fine shales of Scotland and South Africa, it finally happened. A ghost appeared in stone. Not just the elements, but outlines, soft tissue shadows, the faint architecture of a living animal. Conodonts at last had shape. They were slender, eel-like, a few centimeters long, with a tail fin that suggests steady swimming, not crawling. Along their bodies ran blocks of muscle, chevrons like those of fish, evidence of powerful motion through water. And near the head, two dark spots, eyes, not the eyes of a worm, eyes that faced a world of light and prey. Inside, there were hints, delicate traces of a notochord, the flexible rod that predates a true backbone, a structure shared by early vertebrates and their relatives. Suddenly, the argument changed. Conodonts weren't just tooth fragments. They were animals that swam, sensed, and hunted. But they weren't quite fish as we picture them. No jaws, no bony skull, no clear vertebrae. Instead, they carried something stranger. A mouth full of mineral blades, mounted not on jaws, but in a feeding apparatus that moved within the throat. A predator without a jaw. And that is a deeply alien design. Because in our world, jaws are destiny. Jaws reshape ecosystems. They define who eats whom. Conodonts prove that before jaws ruled the seas, other solutions existed. Elegant, efficient, deadly. So how did they feed? And what exactly were those teeth doing? Picture the ancient ocean, dim green light, drifting snow of organic debris, and small animals moving like sparks. A conodont slides through it, quiet, watchful. Its feeding apparatus is not a simple bite. It is a set of elements arranged like tools. Some likely gripped, some sliced, some crushed. Scientists debate the exact motion. Did the elements swing like shears? Did they rake backward, dragging food into the throat? Did they function like a conveyor of blades? What's clear is this: they weren't decorative, where patterns tell the story. Microscopic scratches and polished surfaces show repeated contact. Hard on hard, element against element, over and over. These were working parts, a mouth in motion, and conodonts did not all live the same life. Their elements vary wildly. Needles, fans, combs, spikes, a library of shapes across hundreds of species. Some likely filtered plankton, some scavenged, some hunted small prey. They occupied the oceans for an astonishing stretch of time. From the Cambrian into the Triassic, more than 300 million years. They survived extinctions. They adapted through planetary upheaval. And all the while, their tiny elements rained onto the seafloor, building a fossil record so dense it becomes almost invisible, like dust in the light. But conodonts hold another unsettling secret, because sometimes their elements change color, from pale honey to deep black, not from age, from heat, and that turns them into thermometers of the earth. Conodonts don't just tell time, they tell temperature. As rocks are buried and heated, conodont elements darken in predictable steps. This conodont alteration index lets scientists estimate how hot a region became, a tool used to understand mountain building, oil maturation, and deep burial. A creature that once swam in ancient seas, now used to map the hidden history of continents. But the conodonts themselves lived through a world that was anything but stable. They thrived during periods when oxygen shifted, sea levels rose and fell, and life reshaped the oceans again and again. And yet they vanished. At the end of the Triassic, amid one of Earth's great mass extinctions, conodonts disappear from the record. No slow decline, no gradual fading, just silence. Why? Perhaps their jawless feeding system, so successful for so long, met a new kind of competition. Jawed fishes had diversified. Marine reptiles were rising. New predators, new prey, new pressures. Or perhaps the extinctions altered the oceans themselves. Chemistry, temperature, food webs, changing the conditions conodonts depended on. We can trace their presence in rock like a heartbeat, and then suddenly flatline. After 300 million years of survival, they left nothing behind but their blades. Which returns us to the central strangeness. How can a creature be so widespread, so enduring, and still feel like a visitor from another rulebook of life? Conodonts sit at an edge in evolutionary history. They look like vertebrates. They move like vertebrates. Their tissues hint at the beginnings of a backbone, and their elements are mineralized like teeth, but arranged in a way that no living animal uses today. They are familiar and not. In them, we glimpse an early chapter when the idea of mouth was still being invented, when predators tested different designs before jaws became the dominant answer. Their C's are gone now. Their bodies are almost always erased, but their tiny elements persist by the billions, patiently embedded in stone, waiting for someone to notice that a grain of sand can be a weapon. And in a way, conodonts are still doing what they always did. They guide us through time, through temperature, through the deep history of life. But their final identity remains just out of reach. Were they true vertebrates, or was something just outside that circle? How exactly did their feeding apparatus move? And what other strange body plans flourished in the shadows, only to vanish without leaving a trace? In the quiet of the rock record, conodonts remind us of a larger truth. Earth's past is not a straight line toward the present. It is a labyrinth of experiments, and most of them we will never meet.